Okay, so we're moving on to our next learning objective, and you may notice the numbering system. The first few learning objectives had numbers like this, and this one has a 1 in the second spot, and that's because this is a kind of new topic. It's related to the previous ones, but it kind of starts a different topic, and now we're going to focus on solving equations. So the stuff that we talked about with inverse trig is semi-related to this, but we won't actually see any inverse trig in these videos. But we're going to figure out how to solve equations when we have sine or cosine in an equation. All right, so we're going to have the unit circle again, so we're going to help us kind of determine which angles make a trigonometric equation true. So if we had kind of that example on the first slide, all right, the things that go into our sine function are angles. So we're trying to figure out what angles am I going to put in here to make it equal to a, and a will be some number. All right, one thing to keep in mind, the sine function and the cosine function, the graphs are these infinite waves. All right, so if I'm looking for these to be equal to some y value, I'm going to get an infinite number of answers. All right, so when you look at the practice problems and things, you'll see the word all solutions written a lot, because there's going to be an infinite number. What we'll end up doing is kind of just finding some pattern. We'll try to find 2 of them and kind of just repeat them over and over again, because we know sine and cosine repeat every 2 pi. Every single time you go around that circle one time, you're just doing the same thing, so your answers are going to repeat. So if I can find these kind of first 2, they're going to end up repeating every 2 pi. All right, so that's the goal. Now let's see how we can actually do that. All right, so in this first learning objective associated with solving equations, they're all going to start off like this. We have sine or cosine is equal to a number. All right, real quick, what I'm going to do is I'm going to pause the video and write down that kind of first question from our quiz, which is the 5 special angles we need to know for our unit circle. All right, so this is the thing that we had before in the top right. So you might want to kind of write this down if you don't have it memorized, or we're going to have to use this for all the problems that we do in this video and the next few videos. All right, so make sure you kind of have this written somewhere you can look at it, or you kind of have it memorized. All right, so we're asking ourselves, when is sine of x equal to 1/2? All right, we're going to go back to our original, well, kind of our second definition of sine and cosine, that sine is y values on the unit circle. All right, so if we think about our kind of unit circle, all right, so the whole unit circle in the xy plane, we want the y value to be 1/2. Well, y equals 1/2. If this is 1 up there, 1/2 is going to be right there, and there's 2 different places where that happens. All right, so those 2 angles, all right, the angle going that direction and the angle going this direction, they'll both hit the unit circle at the y value 1/2, and that's going to give me the angle that I put in here into sine to get this answer. All right, so since we have this picture to help us, we can get our first answer. All right, sine is the y value. So if I look at this picture in the top right, the y value is 1/2 right here. So my first answer is going to be when x is equal to, let me make it black instead, x is equal to pi over 6. Because at pi over 6, that angle, the y value point is 1/2. All right, so my first answer is going to be pi over 6. My other answer is not in this picture in the top right, because it's in this angle going to the left. All right, so how can we use that to our advantage? We just found that this angle in there is pi over 6, which means if I kind of flip this picture over, that angle in there is also pi over 6. So I can figure out this angle, this bigger angle that I'm looking for, because it's the full half circle, which you know in radians, our half circle is pi. And I'm going to get rid of this section here, which we just figured out is pi over 6. And that'll give me that angle that I'm looking for. So pi minus pi over 6, I'm going to get a common denominator. All right, so multiply by 6 over 6. And that's 5 pi over 6. So by knowing that picture in the top right and kind of using the half circle to our advantage, you can figure out that our other answer is 5 pi over 6. All right, so those are our 2 answers. All right, when our angle hits there and our angle hits there. And if you remember from the last slide, I said there's going to be an infinite number of solutions. So how do we write that? Well, we just know these are our first two answers. And it's going to repeat every single time we go around the circle. So we're going to put this at the back of our answer. The 2 pi part is the part with how often these repeat. So every time I go around the circle, this is going to repeat. And k just means some whole number. All right, so I can go around an extra 2 times, an extra 3 times, 4 times, any whole number I could put in for those k, and I'm going to get another answer. So I can make k 10, that'll give me another answer. I can make k -5, that'll give me another answer. All right, so this is the kind of format you'll see a lot of these answers in. We have those first two initial angles, and then we say how often they repeat. All right, so keep that in mind. And now you can try this one on your own. So very similar, but sine of x equals the square root of 3 over 2. All right, so go ahead and try this one, and then I'll put up the solution. And here is the answer. So just from that kind of picture we had on the last slide, we get our first pi over 3 is when sine of x is square root of 3 over 2. And again, if I go backwards from the half circle, that pi over 3, I get the other answer is 2 pi over 3. And then finally, with just that kind of repeating part, plus 2 pi k, they're going to repeat. All right, so now we're just going to do a cosine example. Also, this has a negative value, so things will be a little bit different. All right, but cosine, we have our unit circle. All right, we have the xy axis. And cosine, if you remember from before, if sine is y values, cosine is the x values on the unit circle. So we want the x value of the unit circle, that's what the left-hand side of this equation means, to be equal to the negative square root of 2 over 2. Now, if you put that in a calculator, you get about 0.7. So it's about negative 0.7. Let's just say it's there. And again, you can see there's going to be two different kind of places where that happens. All right, that kind of top left spot and that bottom left spot there. All right, so those are the two places on the unit circle where the x value is going to be the negative square root of 2 over 2. All right, and just like all these problems, we're going to use that original picture to help us. All right. None of those values have the negative square root of 2 over 2, but I know this angle, where it hits the positive square root of 2 over 2, is pi over 4. All right, so you can just look at your picture or have it memorized that pi over 4 hits the positive square root of 2 over 2. And again, really similar to the last examples we did. All right, that's going to tell me that little wedge is pi over 4. It's kind of flipping it to the left. I can also flip it down, and it'll tell me that wedge in there is also pi over 4. So how am I going to figure out my two answers? All right, well, the one going to the top left, I can start at the half circle and go backwards. So the half circle is pi. I'm going to go backwards, subtracting pi over 4. Get a common denominator. And that's 3 pi over 4. All right, so this top left angle here is going to be 3 pi over 4. All right, the bottom left angle, now I can go to the half circle, and I'm going more, another pi over 4. So now I'm going to have pi plus pi over 4, which again, really similar except for with a plus sign. And we get 5 pi over 4. And that makes sense because 3 is less than 4, so that's less than the half circle. 5 is more than 4, so that's more than the half circle. But now I know my final answer for this problem, 3 pi over 4, plus how often it repeats, which is 2 pi k, and 5 pi over 4. Again, plus 2 pi k, because that just means it keeps repeating at some regular interval. All right, so cosine, really similar to sine, just looking at x values instead, so I'll kind of help you draw a picture and visualize what's happening. And again, the main thing you're going to be using is this kind of half circle and going backwards for the angles in the second quadrant, the half circle and going forward for angles in the third quadrant. And we haven't had this example yet, but if we did have one in the fourth quadrant, we could start at the whole 2 pi and go backwards to something in the fourth quadrant if we needed that. All right, so those are the kind of ways you can create these angles just from knowing that kind of picture that we had before. All right, so one more time, go ahead and try this problem. All right, cosine equals 1/2. And here's the solution. All right. Because it's a positive value, we can just use that picture and figure out pi over 3 is when cosine is 1/2. All right, that's going to give me that angle, and there is pi over 3. But again, if I flip it over, that tells me that little wedge in there is also pi over 3. So what I can do is take the full circle, go backwards to this angle in the fourth quadrant. That's what I'm doing there. And I get 5 pi over 3 is my other answer. And to finish up, again, a multiple choice question. When is sine of x equals -1/2? All right, so work that problem out, see which of these multiple choice questions it is. And again, just be careful because Edpuzzle, for some reason, randomizes the order of the question. So A might be actually the fourth option. So just make sure you check which letter you're actually checking for whatever you think the solution is.